Hi guys, today we're going to do 9-1. We're going to get into chapter 9 and start talking about rational expressions. And today we're going to multiply and divide rational expressions. Before we start though, I want to do a quick review of multiplying fractions. Okay? So we're going to do multiplying fractions, and there's a couple different ways you can do it. So if I give you the problem 2/3 times 3/4, you could take the two fractions and multiply the numerators. So 2 times 3 is 6, and 3 times 4 is 12. And then what would you normally do after that? You would normally reduce, right? And say that your final answer is 1/2. Well, instead of multiplying across the top first and across the bottom and then reducing, what else could I do instead? So could I take this 2/3 times the 3/4, and could I reduce first before I multiply? For example, 3 goes into 3 once, 3 goes into 3 once, 2 goes into 2 once, and 2 goes into 4 twice. And then I can multiply across my tops and bottoms. So on the top I have 1 times 1, which is 1. On the bottom I have 1 times 2, which is 2. And I end up getting the same answer as before, right? But this time it was a little bit easier, or at least smaller numbers to work with, and I get 1/2. So keep that in mind. What if I asked you to do this problem? So now it's not so basic anymore. It's not just basic fractions. They're still fractions. They're just a little more complex. Now we have rational expressions. We have an x plus 4 over x minus 2 times an x minus 2 over x plus 3. So going back and referring to the example that we just did with fractions, before I tried to get complicated and multiply first, could I simplify by reducing first instead of multiplying first? Could I reduce? But I can only reduce anything on top with the stuff on bottom if that stuff matches. So is there anything on top, the whole group, that matches with the whole group on bottom? Can I take this x minus 2 and this x minus 2 because they're the same exact thing and reduce it? So then what do I have left on the top? An x plus 4, right? And what do I have left on the bottom? An x plus 3? Now I cannot reduce the x from the top and the x from the bottom because it's connected here with a plus or minus sign. So this x plus 4 is connected to each other and cannot reduce with an x minus 3 because they're not exactly the same. If they're not exactly the same, the whole group, then I just have to leave it. So then my final answer would just be x plus 4 over x plus 3. Okay? That's kind of what we're going to do today. Let's look at the first example. Example number 1 asks us to simplify, and it gives us a fraction, but there's a little more going on this fraction. On the top, I have an x squared plus 5x minus 6. On the bottom, I have an x squared minus 36. Now remember, I cannot reduce off my x squared from the top and the x squared from the bottom because they're connected with a plus or minus sign. I can't reduce off the 6 and the 36 because they're connected with a plus or minus sign. So what can I do then to this problem to help me simplify? What can I do at the top? Can I factor it? Looking at this top, what type of factoring would this top be? It's in order, there's no GCF, and there's 3 terms. So isn't this a basic factor problem? So I'm going to take this top and I'm going to basic factor it. I'm going to split out my x squared into x and x, and then I need to figure out what numbers multiply to -6, that when I add them together I get +5. Numbers that multiply to -6, that when you add them together you get +5. Can I do +6 and -1? That multiplies to -6, but it adds to +5, right? Okay. What can I do then with the bottom to help me simplify? The bottom is in order. There is no GCF, but how many terms are in the bottom? Aren't there 2 terms? So if there's 2 terms in the bottom, let's see if we can break it up into squares. I'm going to take this x squared, and I'm going to break it up into x here and x here. And how would I break down that 36? Can I do a +6 here and a -6 here? That way when they multiply I get -36, but when I add them together I get 0, and that's why there is no middle term, right? Okay, now what do you notice in this problem now? Isn't there an x plus 6 on the top? This group can reduce off with the x plus 6 on the bottom because they're exactly the same. No other groups match, so then what do I have left on the top? Looks like here I have an x minus 1. On the bottom I have an x minus 6. I cannot reduce it anymore because they're connected with a plus or minus sign, so that would be my final answer. Okay, let's look at B. Is there any whole group on top that can reduce with any whole group on bottom? Remember, the whole group has to match in order to reduce them. So it doesn't look like I can reduce anything with the top right now with anything on the bottom. But what can I do with all my pieces, all my tops and all my bottoms? Can I factor? So what I would like you to do is I would like you to go through and I would like you to factor all of these. This top left one doesn't factor any more than it already is, but I'd like you to factor the denominator, and I would like you to go through and factor the other two, numerator and denominator. Okay, I'll give you a second. I'd like you to factor all of those, please. All three of these are basic factor problems. What numbers multiply to negative 3 that when you add them together you get positive 2? Can I say positive 3 and negative 1? They multiply to negative 3 but add to 2. This is another basic factor up here on the top, on the numerator on the right side. What numbers multiply to negative 6 that when you add them together you get positive 1? I'm going to say positive 3, negative 2. Does that multiply to negative 6? And it adds to 1, right? All right, last one is another basic factor one. What numbers multiply to negative 3 that when you add them together you get negative 2? Can I say negative 3 and positive 1? They multiply to negative 3 but add to negative 2? All right, so now that I'm all factored, let's figure out if there's anything that I can reduce. If I have a multiplication sign in between, then I can reduce anything on top with anything on bottom as long as they're the same group. So what whole groups can I reduce? It looks like here that I have an x plus 1 group and an x plus 1 group. I have an x plus 3 group with an x plus 3 group. Is there any other group on top that can reduce with any other group on bottom? Doesn't look like it, right? So what do I have left on top? I have an x minus 2. On bottom I have an x minus 1 and an x minus 3. I can't reduce any whole group on the top with any whole group on the bottom, so that would be my final answer. Okay? So anytime I'm multiplying, my first step is to factor everybody, using your rules for factoring from yesterday, and then reduce anything on top with anything on bottom. Okay? I would like you to try one. I'm going to skip try it number 1A, but will you do try it number 1B for me? Here's try it number 1. Here's try it number 1B. Woo. Okay? I'll give you 2 minutes. You have 2 minutes to do try it number 1B, please. top left. What type of factoring is the top left, the x squared minus 25? Isn't that a squares factoring? So can I do an x minus 5 and an x plus 5? Bottom left. What type of factoring is that? 3 terms, no number in front, or an invisible 1 in front, so that's a basic factor. What numbers multiply to 6 that add to negative 5? Ooh, that's going to have to be negative 2 and negative 3, right? So that way they multiply to positive 6, but when you add them together you get negative 5. So be careful with your factoring then. All right, let's do the right side, top right. Squares problem again, x minus 2, x plus 2. Bottom right is a basic factor. What numbers multiply to negative 15, that when you add them together you get positive 2? Can I say positive 5, negative 3? It multiplies to negative 15, but adds to positive 2. All right, who can cancel? I see an x plus 5 and x plus 5. I see an x minus 2, x minus 2. What else? Is that it? All right, so on top I have left an x minus 5 and an x plus 2. On the bottom I have left over an x minus 3 and another x minus 3. Instead of saying x minus 3 twice, could I say x minus 3 squared? Is that the same thing? Either way, there should be 2 of them down there, so you could either write it twice or say squared. There's nothing on top that can reduce with anything on bottom, so that would be my final answer. Okay? While you were working on that try it, I did notice something in the homework problems. There might be some GCFs that you factor out sometimes. So maybe you factored out an x squared here. Let's say there was a GCF that you factored out of an x squared, and maybe you factored out an x squared there. He's not connected with anybody. Not with a plus or minus sign anyway, right? So if I have an x squared here, and I have an x squared here, and he's not connected, they're not connected with plus or minus signs. Could I reduce off an x squared from the top and an x squared from the bottom? Couldn't I do that? Right? So you might have some GCFs that you could also reduce off. As long as they're not connected with plus or minus signs, then you can reduce anything on the top with anything on the bottom. Okay? So we've done multiplication. Now let's get a little bit harder and do division. Okay? Before we get into our division problems though, I'm going to again review division of basic fractions. So if I give you the problem 1/2 divided by 1/4, we don't ever divide fractions. If you get this problem 1/2 divided by 1/4, you don't ever divide fractions. You only multiply by what? By the reciprocal, right? So maybe your teacher taught you saying, change, flip. Maybe your teacher taught you multiply, flip the guy and multiply, I've heard some kids say. You keep your first one the same, you change it to a multiplication, and you do the reciprocal of the second one, meaning you flip it. Okay? So now it's turned into a multiplication problem. And didn't we do multiplication problems just now? And before I multiply across my tops and multiply across my bottoms, can I reduce? So can I say 2 goes into here once and 2 goes into here too? And then on top I have a 2, on bottom I have a 1, and I can say 2, right? So when we have a division problem, we don't ever divide, we only multiply by the reciprocal. Keep that in mind. We're going to do it with rational expressions. So here's example number 2. So now I have a division problem. Okay? Well, we don't ever divide fractions. The only thing that we do with fractions is multiply by the reciprocal. That means I'm going to keep this first one just like it is. X squared minus 25 over x squared plus 2x minus 3. I'm going to change the division to a multiplication, and I'm going to flip the second guy. So everything on bottom comes to the top. Everything on top comes to the bottom. Now I have a multiplication problem, just like the last few examples. And what do I do now? Now I'm going to factor. I'm going to factor so that I can see if there's anybody on top that can reduce with anybody on bottom. I'm going to give you a minute where you factor all 4 of these pieces, maybe just 3 pieces because that guy can't factor anymore. But can you factor all 3 of these pieces for me? And we'll see what we can reduce down. I'll give you a second. Will you factor all of those, please? Alright, I have a squares problem, an x minus 5 and x plus 5. I have a basic factor, numbers that multiply to negative 3, that when you add them you get positive 2. I'm going to say positive 3, negative 1. I have another basic factor problem. What numbers multiply to negative 18 that add to negative 3? I'm going to say negative 6 and positive 3, right? Alright, let's reduce now. Is there anything on top that reduces with anything on bottom? I got an x plus 3 here and here. I've got an x plus 5 here and here. Anybody else? Okay, on top then I have an x minus 5. I have an x minus 6. On bottom I have an x minus 1. There's nothing on top that can reduce with anything on bottom, so that would be my final answer. Okay, I'm going to go ahead and skip B, but I'd like you to do C with me. C is just another division problem, but instead of using the division sign, they use a division bar. It means the same thing. If you don't like it like this, then rewrite it. If you don't like the division bar, rewrite it. Can I say 4a squared minus 1 over a squared minus 4 divided by 2a minus 1 over a plus 2? Isn't that the same thing as just above? But instead of a division bar, I used a division sign. If you don't like it with a division bar, write it with a division sign. It means the same thing. But no matter how you write it, we don't ever divide fractions. We only multiply by what? By the reciprocal, right? So I'm going to keep this first guy. I'm going to change this to multiply, and I'm going to flip this guy. So on top I have an a plus 2. On the bottom I have a 2a minus 1. From there, just like on all the other problems, the first thing we need to do is factor. Before we can start reducing, we need to factor. So let's go through and factor these guys. On this top left, it's in order, right? GCF, well, there is no number I can take out of 4 and 1. We don't take out ones. So I see 2 terms there. If there are 2 terms, I'm either going to do squares or cubes. I'm going to try to do squares and break it up evenly. How then would I take the 4a squared and break it up evenly? Could I do a 2a here and a 2a here? So that way if I FOIL it out, 2a times 2a would be 4a squared. Then how would I break up the 1? Could I do a plus 1 and a minus 1? That way when I multiply them together I get negative 1, but when I add them together I get 0. That's why there is no middle term. Okay, let's do the bottom. The bottom also has 2 terms. Let's see if I can break him up evenly. Can I do an a here and an a here? And let's break up the 4 into a negative 2 and a positive 2. The right side. On the right side, this a plus 2 cannot be broken down any farther. If it makes you feel more comfortable, put parentheses around it. It means the same thing. They're connected with a plus or minus sign, and they can't be broken down any farther. On the bottom, I have a 2a minus 1. He can't be broken down any farther. I can't take an a and break him down any farther than he already is. Okay? So, is there anything on top that I could reduce with anything on bottom? Looks like I have an a plus 2 here and an a plus 2 here. I have a 2a minus 1 and a 2a minus 1 here. So what's left on top? A 2a plus 1, right? On the bottom, I have an a minus 2. I cannot reduce anything from the top, anything with the bottom, because they're not the same group. Everything has to be exactly the same because they're connected with a plus or minus sign. So this would be my final answer. Okay? The more you do it, the more you practice, the better it'll be. Make sure that you follow your factoring steps. If you need to take out your notes from yesterday with the 7 steps and read through those steps every single time you do a problem, then please make sure you do that. You're going to have squares factoring. You're going to have basic factoring. You're going to have cubes factoring. You're going to have GCF. You're going to have possibly grouping. You're going to have all different types of factoring, maybe some bottoms up. Make sure you follow the 7 steps anytime you're doing one of these problems when I ask you to factor. Okay? Your homework tonight is your 9.1 worksheet. I'll collect it and grade it tomorrow, so make sure it's done and done correctly. Behave yourselves.